get started. All right, welcome everyone. Thanks for joining us today. My name is Danica. I'm with 3C Run in the County of San Luis Obispo, and welcome to our course, All Electric Retrofit with Electric Panel Constraints with Nick Brown and Robert Fortunato. And before I pass things off to them, I just have a few logistical slides to go over. So next slide, please. A few quick Zoom reminders before we get started. Please make sure you're on mute throughout the duration of the training, and we highly encourage questions. So if any of do come up, feel free to put them in the chat, or you can raise your hand and we can unmute you. And the session is being recorded, and it will be shared with you along with the slides the next few days. Next slide, please. So just a little bit about who we are. We are the Tri-County Regional Energy Network, also known as 3C REN. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. And we're funded by ratepayer dollars collected through the public goods charge found on our utility bills. And the benefit of being ratepayer funded is that there's no cost to those we serve, and we are able to bring those dollars back into our region. And next slide, please. So we currently offer 6 programs focused on 3 services: incentives, training, and technical assistance. This training today is part of our building performance training program. And if you're interested in learning more, feel free to visit our website at 3c-ren.org. And with that, I'll pass things off to Nick and Robert to get the course started.
Thanks, Danica.
Yeah, thanks, Danica.
Danica is one of the best we work with, so we're all lucky today to be in her capable hands. And we're all just together in San Diego for the KBEC Conference of Energy Consultants, talking about topics just like this for 3 days.
3 full days. It was amazing. So, and Nick chaired the conference, and he did a tremendous job bringing in all these incredible speakers and increased attendance by like a huge number. We had like almost 200 people there, right, Nick?
Yeah, 220. It was great.
Wow, more than 200, 220. That's fantastic. Really fantastic.
Very happy.
Tell them what we're going to do today?
Yeah, and we love working with 3C Ren. I mean, not only do they represent a really beautiful part of our state, but they do a lot of cutting edge stuff on training for the workforce, for contractors installing things, but also designers and architects and homeowners and all different types of people. And we've designed this course accordingly. So we'll do some introductions where we focus on our all-electric homes and some of the panel obstacles we encountered with our projects, lessons learned. We'll cover why all-electric is the way the state's going and the way we all probably should go. In almost every case these days, all-electric makes sense. We'll talk about how the panel size is supposed to get decided, what the National Electrical Code requires. We've done a fair bit of research in this area. And I've been doing some modeling for San Diego's electric utility on what size panel various ADUs require. And then we'll talk about making a small panel work, and power efficient design, I think, is the term that you've coined, Robert, along with a bunch of informative case studies at the end. Did I leave anything out?
You know what? We got to add one more thing, because it may be the most important things in terms of execution. And we have a nice section in there on really how to deal with contractors. And a lot of people just don't want to deal with contractors. And it's a stumbling block because you need, qualified professionals in order to execute on this stuff, a lot of this stuff, let's put it that way. And so we give our best tips and tricks. Nick and I think are a little unique in this space in that we have designed and general contracted our own net zero energy all electric houses. And we went through the process and really got our hands dirty in that process. So we know we've managed subs through that process, and sometimes you want to pull your hair out. It's just what it is.
Yeah, and I'd say most people tend to just trust the contractors. They're the experts. They hired them. And what we've found is you have to drive the project. If
Yes.
your goals differ, and they're gonna, if you're here
Yes.
today, your goals are gonna differ from the standard contractor's goals. So you need to stay on top of them and drive them to the behavior and
Yeah.
decisions you want.
And so our section on that will help you do that. That's at the very end of our process. So we think you'll enjoy that. And to start, we love, a highly interactive class. And I know what people, a bunch of people are going to be pouring into this class, and we have, a good number right now. But if we could ask you just to sign in and tell us where you're coming from, where, in the Tri-County area or outside of it, you're coming from, and then also what you would like to get out of the class. We have a lot of material that we couldn't actually include in the class, but we could pull it in. If you have something very, very specific that you need us to address during our hour and a half time together, we would love to do that. And we want to make this very interactive. And that's the advantage of having two instructors on here. We oftentimes have a running comment section and question section happening in the chat, while the other person can be free to go through and actually talk through the presentation, if you will. So we often have the time for doubling up of the content, and one person's monitoring the chat, the other person's actually giving the presentation. So please put your name in there, where you're coming from, and what you'd like to get out of the class to start us off. And then going forward from here, we have a sort of an important notice. You're going to see actual brand names. You're going to see actual products in this presentation. We didn't want to make it really abstract for people. And but that we don't get paid and we don't endorse any of those products. So we just want to make sure that, you're seeing actual products that you could research. But, always when you're researching those things, put into Google the category class, like, energy efficient, whatever it is. I'm now I'm reluctant to even
Heat
mention
pump
a
water
name.
heaters.
Yeah, that sort of thing. So you're going to see actual brand names, but again, we're not endorsing that. We can't endorse them in the course of this program for a number of reasons. And, we just want to ensure that, you're looking out for these things and you're safe in doing it. So that's, sort of our product disclaimer, if you will. So next, we're going to go through some introductions. I'm going to introduce myself, the project that I did, and Nick is going to do the same. Again, my name is Robert Fortunato. I'm the owner builder of the Green Idea, what is known as the Green Idea House. It's the first net zero energy, zero carbon case study house that was less costly than standard construction. And we use standard construction materials and off-the-shelf technologies, and we came out of the ground 14 years ago. We actually delayed the project for two reasons. We delayed it for 6 months in the build because we were waiting for the first heat pump hot water heaters to come off the production line. We knew that technology was going to be a game changer, and we really wanted to wait until that got done. The second thing is we waited a year to have the ribbon cutting ceremony because we wanted to see the bills. Too often we would see projects and people would say, oh, this is a green project, it's going to do all these things. But we'd ask them, how much did it cost and does it actually work? And they kind of went flush. So we needed the real data. And Nick and I are kind of sticklers about data. And you'll see that through the course of the presentation. It is a normal house. It's not a mansion or anything like that. It's 2,100 square feet. We took our 1,300 square foot house and just added about 800 square feet. We have a 6.5 kilowatt PV array, 26 panels, 250 watt panels. So the array could be half the size today because, it's just 14 years ago. And it's been Green Point rated, Living Building Challenge, Net Zero Energy Pedal verified, and it's still a living lab today. But hopefully you can see from the pictures, Nick and I didn't want to build a spaceship. We didn't want to make some sort of science project. We wanted you guys to look at the pictures and say, I could live there too. That's, it's not so out of the realm of normalcy. We've had over 5,000 people through the project before, during, and after construction, just to show, and we made an open source project to make it easy for people to access. This is what I wanted to see from the projects that we went and toured. And this is our energy bill. This is what it looks like on an, sort of an annual basis. And every one of the bars that is above the line means we're using more energy than we produce. Every one of the bars that's below the line means we're producing more energy than we use. And you can see here, we overgenerate by about 1.7 megawatts per year. That means we have 2 electric cars. We also charge them fully and still come up about net zero energy by the end of the year. If you want to hear the whole backstory of the Green Idea House, we did a TED Talk in 2014. In 18 minutes, you'll hear the whole backstory. And some tips and tricks that we're not going to go into in this particular class. And then from there, I just started working with schools and affordable housing developers and other developers to do some interesting things, which I've listed here. Also, just recently got a passive house consultant accreditation, which is an interesting, and I'll talk about that very quickly. The tenets of that as it applies. But this is the 1959 house on the left, and then we basically just put another floor on the front end of the house that you see here on the right hand side. But it had 1959 stuff in it, technology looked like that stuff on the left, and it was gas, so the whole house was really gas. And we knew that we live in an earthquake zone. Why would I want gas in the house in an earthquake zone? Number one. Number two, there's, volatility to the price of gas. And I can't make gas on my roof. But guess what? I can make electricity on my roof, and I can make it really inexpensively. So that was, those are some of the driving factors behind it. We had one of those old coil, cooktops, and we changed it out to a induction cooktop, which is so incredible, so fast, and so much better than gas. We've cooked on gas before, and we have a bunch of stories about that, but that tends to be one of the things that people kind of clutch onto, like I need a gas cooktop, until they try an induction burner, and it is so much faster and so much better, so much easier to clean up. So we really highly recommend that. This is the production from our solar panels. And as you can see, it's been very consistent over the past 13 years. We did add a couple more panels at the very end because my son built a supercomputer in our house that runs at about 800 watts. And he's doing some very advanced things on it. But we felt like we needed that, with that and it getting a little cloudier where we live year after year. We thought we needed a few more panels. So that's what you're saying there. But this all comes at, for Nick and I, we're trained as economists. It comes down to dollars and cents. And this is just a, very back of the napkin kind of way of looking at it. But we've saved $62,400 over the past 13 years. Basically $200 a month on the house and $200 a month on the car. And it pays itself back, and it pays itself back in carbon too. If you're in, a lot of people say, but use fossil fuels to create those solar panels. In 6 years, that has been paid back, and the panels are meant to last about 40 years. So, this really all does work. And if you don't have an EV, Nick and I have EVs at this point, we know that they're just so much less maintenance. It's basically tires and windshield wipers. And I was professionally trained as a mechanic coming out of high school. And I don't even want to work on my cars anymore, right? There's no need to, with EVs just doing a much better job. And Nick, please introduce yourself and your project.
Yeah, I feel the same way about beer. I was big into brewing, and the beer now is so good, I don't feel the need to brew anymore. I just thought I'd point out that analogy. So I'm in Long Beach, a little south of the 3C Ren area. This is the house that we remodeled in 2015, completed in 2016, inspired by Robert's journey. And he was the little angel on my shoulder saying, go all electric, it works, it's going to be fine. And I was an engineer, I was an energy modeling consultant by then. And my models and all the Energy Code ACE and California Energy Commission sort of treated gas and electricity equally, like they were just two alternate paths that both did the same thing, about the same, pick one, whatever. So I did my remodel mixed fuel with a 16 panel solar array and a really good, efficient furnace, efficient gas tankless water heater. I got the induction cooking right from the start, luckily, and I love our induction range. We'll talk more about that, and a gas dryer. And it performed net zero energy, which was the target du jour of the time. And since then, I've built my business, Build Smart Group. I do Title 24 consulting for architects, builders, homeowners, showing their designs meet the energy code. And I've become an instructor for a wide variety of classes for the utilities in addition to 3C Ren and the Energy Code ACE team, which is the statewide compliance improvement team. After that, we added an ADU on top of my garage, and I've just changed the photo here so you can see it. You can tell we designed it to blend in. And by 2022, I heard Robert loud and clear, and our industry had strongly started to pivot to all electric. The CEC was explicitly saying this is where we're going, as were AQMD and the Air Resources Board in California. Our legislature had passed a bunch of bills that commit us to this direction, and I'd learned a lot. I'd learned just how much better they are, especially in terms of carbon emissions. So we built the ADU all electric. And since then, we've converted the main house to all electric too. And we'll show you some comparison charts. We have a nice 30-something couple living up there, have been for 3 years. They love it. And it's designed to be net zero carbon with a 4-kilowatt solar array. And you can see it's a nice interior. They have good taste, so these photos all look good. For the ADU, we chose a ductless mini split heat pump shown here, 2 indoor units, 1 outdoor unit. They're very quiet. They're zero maintenance once we got them working right, and they are super efficient. We find, funnily enough, the ADU is small enough that it generates a lot of its own heat using the refrigerator and cooking and all the other normal sources of internal heat gains. So the heat pump hardly runs in winter. We used a heat pump water heater, which I installed in the garage down under the ADU so I could keep an eye on it, and because it would remove moisture from our garage space and provide cooling to my workbench. It's been working great. And as you can see here, uses an average of about 30 kilowatt hours a month. Since then, we put in a heat pump water heater for the main house, also working great. And it's a 120 volt unit. We put in this slide-in induction range from Frigidaire. It's been working great. It's got an air fryer. They love it. And we put in this stacked heat pump dryer and washing machine unit from Miele, and since converted our main house to the same pair as well because they've worked so well. We can talk more about those. But our topic today isn't really just about electrification. It's about those panel constraints that can get in the way of electrification. So we've chosen to edit the electrification content as much as possible. Then when it came to electrify the water heater for the main house, you see the gas tankless bolted to the exterior wall down the side of our house. We put in this 120 volt plug-in heat pump water heater, built a little ventilated shed around it, and it's been working great for a couple of years now. And the beauty of those 120 volt units is exactly that. You've already got an outlet there for the gas tankless to run the fan and the igniter. You can just get a 120 volt heat pump water heater and plug it in right there, and that's what we did. We had a gas furnace air handler up in the attic shown up top here. We replaced it with a similar form function variable capacity heat pump from Mitsubishi and plugged it into the same ducts. It's worked great. We had a gas dryer in the main house, and it was in this closet here right outside my daughter's bedroom door. And when the drum developed a crack, I thought, gosh, this might be leaking combustion byproducts into our space right outside my daughter's bedroom door. And it's, even if it's not, it's blowing those combustion byproducts out through the vent, which vents right under her bedroom window. So that's what was my justification to get this heat pump dryer. I stacked it on top of the existing washer at first, and then got the matching washer to go with it. And we have a drop-in induction cooktop and electric stove combo shown on the right. And that's 10 years old and works great. I cook so much more than I used to because the experience is so much superior. So that's a quick introduction to our journeys. Robert, you want to take back control?
Absolutely.
Any questions so far?
No, but we people are starting to chime in,
Oh, good.
which is fantastic. We appreciate that. All right. All right. So now, again, electrification is oftentimes the key driver for this thing. So we want to make sure it's really, really clear why you might be doing this thing. And in our experience, there's a lot of reasons, time, money, aggravation, and your health, or the short answer to it. It's simpler. Anybody who's built a building knows that you don't want, with all due respect to our sponsors and other people at the utilities, you don't want another utility, turning on and off your access to turning your building on. And we've seen delays and expensive, all kinds of things that just say one less utility on a project means the project's just going to go easier and smoother. And Nick is one of the, I'm honored to work with Nick because he's one of the best modelers in the state. And he shows in the various programs that we do how much easier it is to get through the Title 24 process and the modeling as a result of the energy code compliance that makes it easier for all electric buildings versus gas and dual fuel buildings. And you can't get more than 100% efficiency with all gas appliances because they have to make all of their own energies. And heat pumps harvest energy from the environment and use it so you can get better than 100% efficiencies. And these heat pumps, operate between 300 and 400% efficiency. So it's really they're incredible tools that there's just no other way to get there by burning, some sort of fossil fuel. And the safety issues have to do with, two things: fire and explosion. We live in an earthquake zone. The picture on the right, I've been auditing buildings for the last 12 years. And I go into buildings and it's frightening how much money they spend. And, you can see this is a gas array, if you will, connected to the meters that distributes the gas to all of the units in this apartment building. And the amount of money and time and effort that went into, just executing that is ridiculous. And then you can see, and this building at this point in time in its life was about 15 years old. And you can see that those pipes are beginning to rust, right, in an earthquake zone. That's just not something I would, want for my tenants in this affordable housing complex. And so we have so many reasons, for this that you can go through each one of them. But this next chart is really the reason Nick and I are trained as economists. And we wouldn't be here talking about this if these curves didn't exist. The fact is that on the left-hand side, it shows that, solar panels are so inexpensive today. And the price drop has been so dramatic that it's not even about the panels these days. It's really about the implementation and the installation that, are really the things that are most expensive on these things. And the second thing is the battery. Anymore, it just makes sense to put a battery as a result of the changes to NEM, the net energy metering process. And the batteries have been getting less and less expensive. They're still probably the most expensive and the hardest to get the return on investment on, but we're going to talk a little bit about, how to maximize that through our process today. Nick, you want to talk about the incentives?
Yeah. And this has been a moving target. And there are additional incentives offered by 3C Ren that we're not covering here, that maybe Danica can cover at the end. But California Energy Smart Homes is a really good place to start for whole house incentives. That is, you're completely electrifying your house of removing all gas. Well, there's incentives to build a new home that way and to retrofit an existing home or build an ADU that way. There's a base incentive with kickers, sweeteners for doing certain additional upgrades, including $1,000 for electrical panel upgrades, what we're talking about here. Then if you want to electrify one thing at a time, that's where the tech program's designed for. And it's just came back with new incentives a couple of months ago, $1,500 for an HVAC heat pump retrofit and $1,100 in PG&E territory, $2,100 in SCE territory for a heat pump water heater, and increased incentives from there. So those are some of the key incentives to know that can help make your electrification decision a no-brainer. And realize these don't last forever. They run out of money and they get phased out. So if there's something pushing you to sense of urgency, it's these incentive programs. And by the way, we removed all mention of federal incentives from this presentation, although some of those are still lingering out there, the $2,000 tax credit through the end of this calendar year for heat pumps and heat pump water heaters.
Take it if you can.
And let me cover this one too. So when I look at code compliant designs for the upcoming 2025 code, we're starting to dig into the new code and the new software. This is the comparison we see. All of the greenhouse gas emission factors have been updated to better reflect our mix of generation and transmission in California. And so I modeled a code compliant mixed fuel house and a code compliant all electric house in 4 of the most common climate zones we build in, 3, 6, 10, and 12. And in each case, the all electric design had roughly half the greenhouse gas emissions over the next 30-year period. So the life of the mortgage of that home. So that's a really nice soundbite for us to remember. Cut your greenhouse gas emissions in half by going all electric. This has been true now for the last code cycle too. One of the main reasons to go all electric.
Fantastic, Nick. And, you know, if that's not enough, it's really about your health, right? And we know that American Medical Association studies that says that gas appliances increase the risk of childhood asthma. The RMI study said 20% of childhood asthma in California is due to gas cooking alone. So, you know, if you're concerned about yourself, your children, and your pets, really, you know, the gas stove is a big concern, and that's one of the things that we really want to get out of the house as soon as possible, really. And then, Nick, you want to talk about the code compliance?
Yeah, because this chart on the right is the current code due to end December 31st of this year. The 2025 code takes over then. And in the current code, we had an either or heat pump prescriptive standard. Some climate zones had a heat pump water heater prescriptive standard. Some had an HVAC heat pump prescriptive standard, and the other end use could be gas. Well, the 2025 code goes statewide with heat pump water heater and heat pump prescriptive standard. So that's a stronger push towards the all electric designs than we had in the current code. And even if you do choose the gas, you're going to need to make it electric ready. That's the first bullet here, with dedicated electric circuits, plumbing, condensate drains for the future electric appliance. And our compliance metrics directly measure greenhouse gas emissions through what we call the source metric, which make all electric designs far more compliant than mixed fuel.
Yeah, and that first one alone, like who would want to dual plumb all of those appliances for
Yeah.
electric and gas. I mean, that just really, given how expensive the gas plumbing is, it just doesn't make sense at all. All right.
Why don't you
So,
keep control, Robert? Because it's just a
sure,
few in this section.
sure, Nick.
So why are we here to talk about panel sizing? Well, Dee mentioned it. Electrical panel size is often an impediment to electrification. And so there's significant savings to be had if you can make your existing electrical service work for the electrical retrofit project you want to do, thousands of dollars. The project's timeline is shortened too because you need fewer approvals if you don't have to upgrade that panel. You don't have to hire an electrician. You potentially don't have to force an upgrade of the transformer. I've been working with San Diego Gas and Electric recently on issues like this, and they have their rules of thumb for how many homes typically can be served by a single transformer. And they're in the process of understanding how many fewer homes a transformer of a given size can serve when they're all electric. And our research shows it's not that many, not that big a difference. Peak usage of all electric homes is not hugely higher than peak usage of mixed fuel homes. That highest point of usage during the year in a home with air conditioning and a gas furnace may be about the same with a heat pump. So actually, those transformer upgrades aren't always necessary either.
And possibly lower with solar, right?
Yeah, although the utilities can't consider solar when they size transformers because they have to think about the worst case. What if that solar inverter fails? They can't count on it when sizing transformers. They consider it behind the meter is their term, and therefore the customer's, control.
Understood.
Yeah. I like this last bullet too to think about because if we responsibly electrify our home without needing costly increases in infrastructure, well, that saves our neighbors money because all those fixed costs of the electrical distribution system are shared by all of us. So our goal is future proofing. Yes, we want you to have a panel that's capable of everything you're going to need to power your house over the coming 10, 20, 30-year horizon, including EV charging, including if you're planning a pool and spa, including electrification, all electric systems. Solar and battery is a utility that the state government thinks many of us are going to need, but not put in an upgrade beyond what's necessary and cost you money you don't need to spend. And we find this in particular, as we say here, with EV charging, we find people put in 60 amp, 240 volt EV charging services, which charges your car in a flash, yes, but at a much faster rate than's really necessary. And if that's forcing you into a bigger size panel, that may not be the best decision.
Yes.
So this was a postcard I picked up at a trade show recently. There are a bunch of electrical panels that have been identified by insurance companies as more risky. And so you may be forced to upgrade your electrical panel if it falls into one of these categories. And if so, do it, right? This is because they have a history of failure, as they get near the end of their useful life. So there's plenty of reasons to upgrade your electrical infrastructure like this, but this class is designed to help you make what you have work in as many cases as possible.
All right, now we're going to get into panel basics. And what we're talking about here is we just want to make sure everybody's talking about the same thing, because I get them confused. and Nick will point them out to me. He said, no, you're talking about kilowatt hours, not kilowatts. And so just making sure that we're using the right language for the right thing. So let's start with how I learned. Again, I grew up and I was a juvenile delinquent in high school. And so they sent me to vocational technical school for half of the day. And I learned these things. And I remembered how, Nick and I were talking about this class, and I said, how I learned about electricity. This is how they taught it at Votech. They said it's just like water. So if you think about that in that analogy, it really kind of makes sense. So pressure in a water system, right, is determined by, how tall the vessel is, if you will. And on the right-hand side, you can see a pumped hydro storage analogy. And that diagram shows you that you would get more pressure if that upper reservoir was higher up the mountain, right? Taller, if you will. That adds pressure. And in electrical terms, that's voltage. You think of that voltage as that pushing power. And the second thing you have to think about is the flow. So depending on the pipe in that hydropower storage, if you made a bigger pipe, you would get more flow, which would give you more power ultimately. The pressure and the flow give you power. And the same thing, the amps are the same thing as the size of the pipe, if you will. And if you have a bigger pipe, you can carry more amperage. Smaller pipe carries less amperage. So that's how the two kind of combine together. There's another concept in there, which is ohms, which is resistance. And that still has to do with the size of the pipe or restrictions in the pipe. But we don't need to, really think about that in terms of what we're doing today. So pressure times flow equals power, volts times amp equals watts. And then when you have 1,000 watts, you end up with a kilowatt. That is something that we're going to be talking about a lot. So we have to understand that is the measure of power alone. If you multiply that by time, you get a kilowatt hour. So if you use 1,000-watt appliance for 1 hour, so it's the amount of energy, a kilowatt hour is the amount of energy used by 1,000-watt appliance running for 1 hour, right? So that is a kilowatt hour. And the two really have to be paired with each other. The kilowatt is the flow, like the pressure that's going into it, times the flow, and that gives you the actual power. The kilowatt hour is a measurement of that power over time. So we'll see how that plays out. So for example, a battery is measured in, battery capacity is measured in kilowatt hours in terms of how long it will last, and in kilowatts in terms of how much power it can instantaneously deliver in that moment. So that's how a battery would be rated, for example. So as Nick very astutely mentioned, we run into situations where people want to put in super fast charging into their house when they actually don't need it. My next door neighbor wanted to put a 240-volt charger in his garage. And I said to him, Lou, how much do you drive in a week? He said, well, I drive, to the gym, and then I drive to the supermarket. And I said, how often do you do that? And how far is the gym? The gym's 1.5 miles away, and the supermarket is less than 1 mile away, right? And I said, Lou, you just don't have that kind of need for a fast charger. He's retired, and that car sits in the driveway all day long. So he actually can get away with a 120-volt and doesn't actually need to go to a 240-volt charger, and he would have plenty of capacity for everything that he needs. And if he needed to take a long trip, then he could use a supercharger. So it's, just have to think differently about these things, because it really does affect the size. This is maybe the biggest load that you will run in your house, period, is the charging of your car. So if you had an 80 amp panel, you could, potentially have 19.2 kilowatts as a capacity for a full capacity for your house and everything else. The 100 amp panel, 240 times 100 amps, gives you 24,000 volts or 24 kilowatts, or I'm sorry, 24,000 watts or 24 kilowatts. Again, that steps it up. So it says you have more capacity to do more things. 200 amp panel gives you a lot of capacity, 48 kilowatts. I have a little meter on my desk. I wish I could show it to you. It's the dumbest little meter, but it shows me what my total output in a moment is in kilowatts. And I've never seen it go above 12. And that's like every single thing that we have, you know, cars charging and the heat pump hot water heater and the you know, and we're cooking dinner at the same time. Like I've just never seen it go above that. So if you look at the total capacity of these things, 48 kilowatts is a lot of power. It's just a really big panel, and many buildings just don't need that much power. And then as Nick mentioned, you know, we've been metering these buildings now. All electric houses in California, on average, uses about 12,000 kilowatt hours per year. So about a kilowatt a month is about what a kilowatt hour a month is what they use. The average is about 1,000 kilowatts a month. You times that, you know, the average rate in Southern California Edison territory is about 32 cents. That means your average bill would be about $320. The average peak load is about 10 kilowatts. As I mentioned, I've never seen mine go above 12. And we have a 6.5 kilowatt solar system that generates 6.5 kilowatts at peak. So Nick and I have been really thinking about how much electricity from the grid costs. So if you can keep your electricity usage below what your the energy generated by your solar system, and you don't have to buy that external power from the electricity from the utility, you can save a lot of money. And that's a concept that we really want to drive in here. So I want to keep my load under 6.5 kilowatts at its peak in the summer, and it's going to go down from there in the winter or at the end of the day. So I'm really trying to time things to maximize my car charging and everything underneath that 6.5 kilowatt umbrella, if you will. Nick,
can I give a funny example?
Please.
We woke up this morning and my wife's like, "Did you run the dishwasher?" I said no. And she immediately thought, there he goes again, not doing what I asked him to. But I said, I'll tell you why I didn't. I wanted to wait till the sun was up on my 4.4 kilowatt solar system and run it off solar.
That's right.
These are the types of conversations we have. It's so funny.
Yeah, my wife says, "Listen, I don't want to hear from the Watt Nazi. We need to run the dishes now, right?" There are times for that, right? And sometimes you just need the dishes, and other times. But if you can wait, there's real advantages to that. And our machines now have timers on them too. So even if I'm running out the door, I can set a 2-hour timer until it, you know, we get to the 10 o'clock hour and we really have some production. Because where we live too, we have a cloud cover until about 10 or 12, oftentimes, you know, during June gloom times. So if you can hit that timer and just stay under the umbrella of that thing. But yeah, my wife doesn't like it sometimes when I, you know, sort of insist. We're going to save some money here. Okay. So as Nick mentioned before, you know, a lot of people just don't need that much car charging. And if you plug it in from 4 to 9, it will be very, very expensive to charge your car during that period. So if you can charge it during the day, that's optimal. And if not, after the 9 o'clock period. And if you use a 120 volt, as my next door neighbor is now using it, 15 amps, he only uses 1.5 kilowatts per hour, and he gets about 6 miles per hour of doing that. So he just doesn't drive that much. So that's plenty for him. Overnight, he, you know, it has plenty of juice for the next day. If you did want to put it in a fast charger at 240 volts at 20 amps, you get 4.8 kilowatts per hour or 19 miles per hour. And that's more than enough. The average person doesn't drive more than 50 miles a day. It's very unusual for somebody to drive more than 50 miles a day. And if you really wanted to put in the fast charger, that's the 50 amp model at 12 kilowatts. Most cars can't take 12 kilowatts. That's the reality of most production EVs at this point. They generally run at about 7.5 kilowatts. And that's the max. Some do go up to 11, but I haven't even seen a 12 kilowatt hour or 12 kilowatt EV at this point. So the fact is that most people don't need 48 miles per hour, and because they're charging overnight or extended periods. And if you're charging at 12 kilowatts, you are certainly breaking through, unless you have a very, very large solar system, more than 12 kilowatts, you're going to be breaking through that envelope and paying the exorbitant utility rates for that electricity. All right, now Nick's going to cover calculating panel size.
Yeah. Maybe pause for questions. Any questions so far?
Yeah, I haven't had a chance to look, but everybody's chiming in, and I appreciate that. I haven't had a chance to. Did you have a chance to read, Nick?
Yeah,
Anybody?
not a whole lot of chatter there, so I thought I'd give them a quick pause if they wanted to.
Yeah, but people are doing projects. We have a lot of architects who are doing projects, and they want to understand, how can I keep the client from having to do this thing that nobody wants to do? And that's what we're digging into. So appreciate that.
All right, well, let's keep going then. So we've investigated this quite a bit and talked to electrician friends and engineer friends to understand it. The code that governs electrical panel size is the National Electric Code Section 220, or NFPA 70. And it allows for two different methods. One is load calcs and two is historical usage. Under method one, which we're going to show you in a spreadsheet, you outline each of the electrical systems going into your building. There's a base load calculation that's a function of your conditioned square footage area. Then your HVAC system gets counted at 100%. So they want to make sure we have plenty of electrical power to run that HVAC system that's going to be on a lot of the year. EV chargers actually get charged an extra 25% penalty above what they're rated for. And then our other circuits, these are washer dryers and cooking and all your other appliances, they get valued at only 40% of their max load because so many of them are going to be operating only occasionally, and they call this a coincident multiplier. So you'll find that if you look at your panel and you add up all the wattages in your house, it's going to exceed what your panel can power because of this 40% coincident multiplier. And then we size the panel to the sum of these calculated loads. Alternatively, if we have an existing home with history, we're allowed to use the actual usage for a year, which we can all download from our utility, often called green button data, or we can use a power meter for 30 days and just take the maximum usage in that history and size our panel to that. If we were doing a remodel, let's say, we'd have to take the historic and add any delta onto that. And so that's a recognized method as well. But an important note, generally solar and battery systems are ignored for the purpose of calculating power requirements, panel sizes, because they could fail. An inverter could drop out and that solar system could stop serving the home, and the electrical company wouldn't want that to cause overloads. Similarly, the battery, if we were counting on it to get us through 4 to 9 p.m. and it failed, so historical data can't include a renewable energy solar system. So your electrician likely, when you call them to ponder a remodel, they're going to know this electrical code. They may not all do the calculations, to the full extent and detail of what it should be, And they know it's safer to exceed the capacity than to underestimate it. Better to have too much power. And what we're seeing is many of our clients are being pushed from a 200 amp panel to a 400, from a 100 to a 200, with significant cost implications and time implications, when electrification is labeled as the culprit and quite often is not. Okay. So our advice for managing your electrician is show them your history, um, make a full list of the systems you plan to install and their power requirements, and force them to do those calculations and show them to you, while future-proofing for EV charging if you don't have it yet, solar panels, batteries, and other needs. We don't want to hold you short either.
Yeah, and Nick, I told you the story of a potential client who came to me and said, we'd really like to electrify our house, and I said, super, and here's the things, and this gentleman came back and said, my wife absolutely has to have gas, a gas stove, wants gas barbecue, wants gas for the pool, and and I said, well, I'm probably not the consultant for you. So they get through halfway through the build, and he calls me back and he says, my contractor wants to put a 400 amp panel in. And I just, and it's going to be an additional $9,000. And I said, I would have been happy to work with you early to avoid that. But you certainly don't need a 400 amp panel for a 2,100 square foot house with gas. So that's the kind of outrageous stuff that we see on a regular basis. And just the contractor just wanted to make some more money. And that's what happens, unfortunately. So this class will show you how to avoid that kind of thing.
Didn't you run into this equation in your project?
Yes, that's exactly right.
Yeah.
And we have to avoid it.
It's this sort of abstract conversion. You can't convert gas to electricity, right? I mean, you can with a power cell from Bloom Energy, but this is sort of it's a conversion that isn't real. And so if your electrician is taking gas usage times a factor to calculate electric usage, they're not going to enough detail.
Yeah, and they will end up with a far, far bigger load than you need.
Yeah. A note on gas houses and their electrical panel. Remember I said that the 2022 Energy Code requires you to be electric ready if you install a gas system? Well, that only applies to new homes. But if your project is a new home, well, you need the electrical panel space for the future electric appliance, even if you design it to be gas. So it's going to be reserved in your panel for future. So designing with gas doesn't help you downsize your panel in that case. Now, for a remodel, sure, if you've already got gas and gas is, your furnace and your water heater, then you save the panel space for, those end uses. But new construction, you don't. So there are a few tools we wanted to share with you, starting with Watt Diet. And we've been using this to support our clients when they get feedback from electricians and general contractors that they'll need to upgrade their panel. And in some cases, they're absolutely right. It's a big remodel. The existing panel was 100 amps. Yes, it needs to be updated. But we've found just as many cases where we could show using these tools that the existing panel was adequate. That's what led to the idea to teach this class for 3C Rent. So what this spreadsheet shows is you put in the size of your home and your typical insulation levels, and you see up here up top, it's calculating the base energy use. That's all based on certain multipliers for lighting and plug load, a kitchen countertop circuit that every home has, and a laundry circuit that every home has. That's why they're in gray. They're sort of automatic, defined by your size of home. But then all these other loads are elective, right? They're up to you to define. And so you put in the voltage and amps, it calculates the power, it multiplies each end use by those coincidence factors, 1, 1.25, or 0.4, sums it up and picks the next biggest panel size. They're generally available in, 80 watts, 100 watts, 125 watts, 200 watts, amps. And so it kind of sticks to what's available on the market. And we'll give you these slides, by the way. I should have said that up front, with the link to Watt Diet Calculator, but Robert's given it to you here too in the bullet below. Free to download, just an Excel tool that does the National Electrical Code calculations for you.
And Danica very nicely put it into the chat.
Okay.
Thank you, Danica.
Keep in mind, though, this tool is designed for climate zones where the heating peak load is higher than the cooling peak load. If you're in a climate zone like Palm Springs, where the peak cooling exceeds the peak heating, don't let this tool size your heat pump for you. Size it yourself or with your HVAC designer. But probably 2/3 to 3/4 of California climate zones with today's code compliant envelopes, the heating is the higher load, and this will work just fine to define the right size heat pump for you. But if not, you can just go here and override the heat pump power that's required.
Nick, we have a question from Yen. If I have gas in the project, can I still use this tool?
Yes. In fact, that's what we've got here. We're showing no heat pump, and we're just showing the air handler for the furnace. You see that? This was a mixed fuel Watt Diet.
And Carlos says, what if heating and cooling loads are similar as it pertains to the Watt Diet calculator?
Then you're good too, because if you size it by heating and cooling, you're going to come up with the same size heat pump. Yeah, but
great questions. Keep them coming.
Good questions. And this is just a zoom in of that original version.
All right.
So we've got some tips for making small panel work, and then we're going to come back to that tool to demonstrate it a little more fully. Robert,
absolutely.
Back to you.
Yep. So we wanted to, dig in a little bit more, and we're going to do that by really just walking through the steps, right? Choosing power efficient appliances is always a good idea. Using high efficiency appliances, 20+ SEER heat pumps, for example, circuit sharing pausing devices that we'll show you, and making sure that you're right sizing the HVAC will give you tips for that, and decreasing your loads, especially on HVAC. That tends to be one of the other than car charging, that tends to be the biggest one. So power efficient appliances are key, and the heat pump hot water heaters are real energy sippers. And again, I delayed our project 6 months because I just knew this technology was such a game changer. And they were always 240-volt units because they would put a 4,500-watt resistance heater in the tank just in case the heat pump couldn't keep up with the load. But what we're finding is the heat pump actually does really, really well, and you don't need the 4,500-watt resistance heater in the tank. In fact, we programmed ours so it never uses the 4,500-watt unit in the tank. And then we just communicated that to manufacturers to say, if you don't need the 4,500 watt unit in the resistance unit in the tank, you actually don't need a 240 volt line to the unit. You can run it off of 120, which means I can plug this thing into the wall. That makes retrofits just that much easier, that you don't have to get an electrician to run a 240 amp line to this place that used to have a gas hot water heater. And so you can basically just dump that thing down there and plug it into the wall. And that's the advantage of these new models. And that's what we're recommending these days, is to just use the 240 volt, because we really don't recommend leaving the 4,500 electric resistance, because that'll push you into that next tier again, in terms of having to make a space in your panel box. And then also it just elevates the threshold for which you might have to use energy in your entire load. So if 20 amps will do the job, it's better than 30 or 40 amps. For HVAC systems, again, run the calcs to see if a 20 amp HVAC system will work instead of a 30 amp. And on water heaters, never choose all electric. Use a heat pump hot water heater, again, for the reason that I just articulated. And again, there's still great incentives on these units out there. High efficiency appliances, that's Nick's HVAC unit. The more efficient the appliance, the less electricity it needs to do the same work. And a 21 SEER heat pump does 50% more work than a 14 SEER air conditioner. So again, the same thing. We're trying to reduce our overall load. And refrigerators, choose one that's and it has that giant sticker on the front. And this is what they're talking about. Use one that uses 700 kilowatt hours per year, not the 1,000 kilowatt hour per year water refrigerator. Same thing for water heaters. Generally, they're in the range of 3.5 to 4.5 coefficient of performance, and that tells you that it's 350% efficient if it's 3.5 COP. Electric tanks are a maximum 96% efficient, so they use 4 times more electricity. And some people have come to me and said, well, shouldn't I use just a tankless electric unit? And again, there's a giant spike, and you're going to have a dedicated circuit for that thing. We're trying to get out of the dedicated circuit so you have more room in your panel for doing different things like solar charging, EV, or solar and EV and other things. So that creates space in your panel for these things. Ranges, induction range is 80% efficient, electric is 60% efficient, and gas is 40% efficient. This, we do recommend the 240 volt version of that thing. It will take a space in your panel, but in our experience, the cooking experience is so much better. It's twice as fast as a 120 volt version, but we'll, in the cooking section, we'll go in and show you a 120 volt alternative if in fact it's too difficult to get that 240 line and service to that spot in your house. Load management devices are coming on really strong, and they're so smart and so effective. When you have more load in your panel and service than the panel can deliver, these circuit devices can control how much power is being delivered. So you can install two appliances on one circuit with a circuit sharing device, which we'll show you in a second, and install 2 appliances on one circuit with a circuit pausing device. So for example, if you're running a dryer and your EV charger off of the same circuit, you can choose which one has a priority. That is, if I want to finish my clothes, then the car pauses while I'm doing my laundry, for example. And that's probably makes sense. You know, most people don't have that urgent of a need to charge their car, but you don't want moldy laundry, right? You know, you want to prioritize things of that way. And then there's a smart breaker box, which manages your loads through a box. And it replaces the panel, the breaker panel. And you'll see one brand name is Span. They've been doing a good job in the space. And so on your phone, you can say, and have it do the same thing. I don't want my car charging right now. I want to run the dryer, and it will limit the load so that you don't overload the system. And again, what's the worst thing that happens if you overload the system? It's usually that the main breaker breaks. Okay, so that's what the main breaker is for, if you have too many loads. So you know, we don't want to say it won't start a fire because, you know, for liability reasons, but really what happens is the panel main circuit breaks. And then you have to figure out, what that is. But that's, essentially what the outcome of overloading the panel is. When you need more physical space for breakers, there's a tandem breaker that you can use. And we did this in our house. Just the electrician just didn't anticipate how many individual loads there are in the house. And so we used a lot of these tandem breakers because you can get two in the same slot. You can get two lighting circuits, for example, in the same slot, and it keeps you from having to have more sub panels than you really want to have in your house. You can also join two low load circuits together for lighting, for example. Our lighting circuits were designed for 100-watt bulbs, oftentimes, in the 70s, 80s, 90s, and throughout. And now, that same 100-watt bulb fixture is using 20 watts maximum. So really, you have a lot more capacity in the panel than you used to have as a result of LEDs and other very, very efficient things. We're going to show you a solar collar meter in a few slides, so I'm going to hold that. But these are the load management devices that we're talking about, where you can plug two loads in and have the first two pictures are of those kinds of splitters. And the third one I want to mention, because a number of car charger manufacturers are now making chargers that also come with CTs, which plug onto your main load coming out of the breaker box. And it basically monitors to say if you're charging your EV and it's approaching the maximum output of your breaker box, it will lower the charging rate to accommodate your breaker box and make sure that you don't break the main breaker in there. So that's really smart technology. And it also does one other thing. If it's also monitoring your solar system, it can keep the EV charging below your solar production, so you're not using the grid electricity. And again, that could save you a lot of money over the course of years.
Hey,
So
Robert,
really smart technologies. Yeah, Nick, please.
Carlos is asking if you can use those tandem breakers for 240-volt circuits.
240 volts will require the full breaker because you have two lines in, and you don't have the space for those in the tandem. So unfortunately for the two, and that's why we don't want the heat pump hot water heater, for example, to be 240, right? Because it's going to take up a full space, and you could use it for other things. Great question. Great question. But yeah, we really want to limit the number of 240 volt of appliances in our house. So the car charger and the induction cooktop are really the only two major ones.
Oscar says there is a way that will work. So
oh, no kidding. No kidding.
Yeah, I haven't
Thank
seen
you,
it
Oscar.
either.
I haven't seen it. We need to research that. Oscar, can you send us a link or something on how that does work? Tandem double pole will work.
Yeah.
I haven't seen it, but I would love to see it.
And I'll clarify on the water heater. The one time where when you want 240 volts is when you need the electric resistance backup element, is when you're putting your heat pump water heater somewhere it's going to be subjected to outside air below 40 degrees Fahrenheit for at least part of the year, because that's when you want that resistance to kick in. So if you're putting in an outside closet like I did, not in a temperate area like Long Beach, you may need that 240 volt, or you may need to find a location inside.
Yeah. So so if you've got your house in Truckee, for example, right? That might be the place, right?
That's right.
In our temperate environment where it doesn't freeze, don't get the 240, do the 120.
Yeah.
Great. Excellent. And this is the meter collar for PV. This is an innovation that really is helpful for people who are stuck and they don't have spaces in their panel box to put the PV. And this is a great innovation. So there are a number of manufacturers came forward and said, hey, there's a better way to do this, and just attach it to the collar of the meter that goes onto the house and directly connects that way. Right sizing HVAC systems are commonly sized 2 times the maximum load. And this is a real problem. A lot of people think, well, I've got a bigger box that's better, you know, just in case kind of thing. And the fact is that we know from doing way too many classes on the subject that these systems tend to come on and come off and come on and come off. And as a result of that, you're actually burning out the system. So the lifespan of those two times maximum load systems burn out much faster. They use a lot more electricity and energy than is needed. And it's called short cycling, where it's just, you know, continually turning on and off and on and off. And the lifespan of them is greatly reduced as a result of that. You'll want to pay for an ACA manual J load calculation that basically goes around and says how much insulation do you have in the walls and the ceilings and the, and so as a result, how much does this building in this climate zone actually take to, how much energy does it take to keep it heated and cooled? And that's what that manual J load calculation does, which helps you size the HVAC system appropriately. If you
Yeah,
can
Robert,
go,
when
yeah,
we do
please.
these load calcs, we regularly find 800 square feet per ton with today's building envelopes meets ACA Manual J. And that's an average across climate zones, so don't quote me. But HVAC installers, on the other hand, generally use 500 square
Yeah.
feet per ton as their rule of thumb. So that just shows you how far off the old rules of thumb are from actual load calcs.
Yeah, my guy said the rule of thumb was 400.
Okay.
So yeah, it's bad. It's bad. They don't, you know, and again, they're trying to, you know, cover CYA, right? It's just, you know, if you put a bigger thing in their thought process, well, I'm not going to get a callback if I put a bigger thing in there. But it's quite the opposite. It just takes longer, but their units are going to fail. And we want to choose reasonable size cooking, laundry, water heaters, pool heaters, etc. So, you know, just thinking about the sizing of these things is really important. And there's 2 code changes. And my friend Spencer Rosen, who has done deep work in this space, led us to this understanding that there's a section 220.70 that allows the use of digital energy management systems like the SPAN panel to limit the maximum current used by the electrical system. So this was not always the case. And it, no matter what kind of panel you had to calculate the loads and then, you know, go with the maximum. And this allows you to do something really different, to scale down what your needs are and not have to get a panel upgrade as a result of upgrading to something like the SPAN panel, which allows you to manage the amount of energy flowing through. The second innovation is the thing I referred to earlier. Section 625.42 recognizes modern vehicle electric supply equipment, EVSE, equipment with adjustable settings and energy management systems, which allows for more flexible and cost-effective installation. So again, this unit alone might keep you from having to do a panel upgrade, given section 6.25.42. Hope that's helpful for folks doing that work. All right, now we're going to move on to case studies. This is our house. Again, you saw the pictures of it before, and these are our panels. On the left is the upper main panel, which has the meter on it and the AC disconnect for the solar system that you see there. And it's a lot of little breakers, isn't it? And guess what? Our electrician couldn't get them all in there, so we had to put a sub panel. And what you see on the right-hand side is the sub panel for the stuff in the garage, basically. So we have a north side charger and a south side charger. Tip for folks, I would never do that again. You don't need 2 car chargers. Never in my experience did we need to charge both cars at the exact same time. In my thought process, I thought that might be helpful. But as a result, I have an open breaker. Basically, I can take that thing out because we never use 2 chargers at the same time. So anybody's contemplating this, just not necessary. And I put the charger toward the front end of the garage so I can run it out to a car in the driveway or to the other car in our 2-car garage. So the cords are long enough to go across and out quite nicely if the placement of the head of that thing is toward the front end of the garage. And again, we have a 240 breaker in there for the heat pump hot water heater. And we have 2 of those tanks. One of them is an 80-gallon tank for our hot water system, which runs our heating system through baseboard radiant heat. And the other one is for domestic hot water. But again, I have an extra breaker in there because I could install a 120 volt unit without having, so it's nice to know that I have the capacity. If I ever wanted to switch that unit out, I would have an extra breaker, and I think I could use it as I'm contemplating, future loads going forward. This is a point that I want to make very strongly because it is really one of the triggers. Because when we were contemplating, do we go all electric or do we, put more gas in the house? Essentially, we had a 3/4 line running from the street on the other side of the house where the gas meter was. And if we wanted to put gas into the house, we would do a tankless hot water heater was the sort of the thing to do in the day. But the tankless hot water heater needed a 1-inch pipe. And so we had a 3/4 inch pipe, so that wouldn't work. So we would have to retrench. And if we retrenched, we would have to have a dedicated trench just for that gas line. And that would have been back then $7,000. I'm sure it's more today. But you have to get those guys, they tap into the main breaker or the main pipe and all that stuff that needs to happen. And we said, okay, you can buy a lot of solar panels with $7,000, right? So what we did was this trench that you see on the left-hand side. So we could put sewer in that trench. We could put the electrical in that trench. We could put all our low voltage communication stuff all in the same trench. And a tip for you guys, we were going to take this building down to the studs and then build it back up again. And we were contemplating a power pole that you would need to get the, as we would need to replace the breaker box. But we thought, hey, why not, in advance of taking the building down, do we not just replace the panel? And that saved us a ton because we didn't have to get a temporary power pole, which tends to be expensive and, and sort of in the way of everything else that you're doing. We knew where we wanted to put the new panel. We put it on the other side of the house. We installed it, dug the trench, did all that work before we moved out of the house. And that's just saved us a ton of time, money, and aggravation versus buying a power pole. And you're always paying commercial rates when you're using a power pole. So just for those guys sawing and doing all the rest of the stuff, we could just use our regular panel, which was just installed in the studs. They took the rest of the building down around it essentially, but kept those walls up. And that's just a tip that I pass on to people because I think it could save you a ton of time, money, and aggravation.
Robert, low on time, so.
Oh, yep. One thing I also want to mention is to install a surge protector, a whole house surge protector, because that can also save you a lot of the equipment, especially the inverters are not covered if in fact there's a surge from the Southern California Edison, and so highly recommend that. Little bungalow, a friend of ours has a little bungalow and they wanted to electrify everything, but they only had an 80 amp panel. And so we went through the process. We put in some EFOCA units, which can run on they do run on 120 volts, and they can do about an 800 square foot space. So this worked perfectly. We put one in the main living room, one in the bedroom, and they also come with MER13 filters and an HRV in there, which basically makes it super, super efficient. We put 120 volts heat pump washer dryer combo in the unit, which just plugs into the wall and no breaker needed. And we put an induction 120 volt induction unit in there, but we could have used one of these units, which are really tremendous. There's a battery in these 120 volt induction cooking units, which gives it the power of a 220 unit, but you only have to plug it into a 120 unit. So there's a couple of brand names there. You can look those up. And Nick, you want to go over the 80 amp panel that we ended up with?
Yeah, so we were able to show for that little bungalow that it could be remodeled all electric with 80 amps. And that's with an EV charger. You see that Yeah, you can't see my screen, can you? That's with an
You can see
EV
it there, though.
charger, and I think
Yeah.
it's with a full size induction range. We actually were showing in there 41.6 amps, and you had less than that. So
Yeah.
surprising sometimes. Yeah.
You can do a lot with 80 amps.
Why don't
So
you
that's the
keep
point.
control and I'll just talk through my
Yep.
case study. So the main house had a 200 amp panel at the time we added the ADU. The main house was at the time mixed fuel, but we were planning to electrify it. And we were adding this ADU with a 4 kilowatt solar system. Question was, could we do it with an existing 200 amp panels? And this is a situation very familiar to probably many of you. Next slide. So the main house had only 125 amps of service, but a 200 amp panel. I didn't realize that. They'd never actually run the full amount of power to the house that the panel was able to distribute. Those are two different things. So what we found was 125 amp service, plenty for the house, 100 amp service, enough for the ADU. And Edison required us to put in this dual meter main panel. The main house panel became a sub panel for the main house. So we added a second sub panel for the ADU up in the hallway of the ADU, and everything worked great.
And Nick, you knew that it was 120 amp service because of the breaker, correct? Despite the fact that it had 200 amp panel.
Didn't know till we took it apart and saw that, yeah, that main breaker was only 125 amps.
I just want everybody to know that's how you know, right? It's the main breaker. The number on the main breaker is how you know, because the panel could be sized for something else, but it's the main breaker that you're really looking for.
Yeah, so you can see those two breakers there in the main panel. And then this is the sub panels, able to distribute fully all electric, everything with that level of power. Haven't had an issue. And we used Watt Diet to prove it. 125 amps for the main house on the left with a 40 amp 240 volt EV charger, which we put in early on and oversized it in retrospect, with the future heat pump, water heater, and heat pump that we planned. And then for the ADU, it was only 60 amps actually that it would have needed. And so it's got 100, more than enough. So you see how we can apply Watt Diet to real world. Then we went and looked at this 10 unit existing multifamily project. They were facing that problem on the postcard we showed you earlier, where their electrical panels were old enough and identified as problematic by their insurance company. They needed to upgrade them. We showed they could increase to a 600 amp panel and serve these 10 units by showing Watt Diet only needed 50 amps per unit, plus another small panel for the laundry room and water heater. And then a contractor came in and did us one better. They said, if we put in these copper 120 volt cooking ranges, we can do this with 400 amps. So I thought that was so cool and a
It's
great way to
amazing.
show the value of those lower power appliances. And here was one
Love
of the
this.
residents who got so excited about the prospect of electrifying their building. She got this little induction cooktop and started using it instead of her gas range. And there you see the 50 amp calculations that we could electrify each of those units with.
Beautiful. All right. So in our last portion, we want you to go and try these things. So we've created a scavenger hunt for your own houses. And, it allows you to go around and take a look at what you're currently using and how it could be transformed from an electrification standpoint and how, what it's going to look like. So you'll see a link at the bottom right there. So that link will get you to this document. It's a Google document. There's several pages, but you can basically print them out and walk around your house and then find these things. And that'll help you in the process of documenting for use in the Watt Diet or other things that you're looking to do. So last section, we're going to do really quick. Working with contractors. it's so important to be clear with them on the outset. And sometimes you don't know what exactly you need. Hopefully this class will have given you some of the parameters that you want to look into to say, hey, we want to do a heat pump hot water heater, and we only want to do it 120 volt, right? That will be more information than, in our experience, than most contractors know about heat pump hot water heaters, right? So they just aren't familiar with the technology yet. And so if you can guide them in that process, that's super helpful. Have a written project requirements document. The document that we gave you will help you make that requirements document. Detail the work that you would like performed in the product specified. When you're qualifying, ask for referrals. It's super helpful to talk to other people who have dealt with those contractors to say what worked well and what could have done better in terms of communication or the actual output, the quality of the work, the quality of the subs that they hired, so forth. Platforms and reviews can give you leverage. The thing we learned about our house is that the contractors were also dealing with really large developers who had more and more and more projects for them. We just had one project. And as a result of that, they could have ignored us. But in the age of reviews, if you could promise to give a good review, that has a little more sticking power. So Home Advisor, National Association of Remodeling Industry gives you, Thumbtack, Yelp, gives you that, leverage, if you will, over the contractor. But again, give them a great review if they've done great work. You're looking for license experience references on the work, specifically the work you need. How many electrification processes have you been through? How many panels have you replaced? Like, you want to know that they've been through this before, so that they're not charging you for your learning curve. You want to check the state contractor's license board to make sure that they don't have a sort of a ding against them. The Better Business Bureau and places like Thumbtack interview each of them. You'll learn about them and the project. You want to ask them who's already, you want to ask who's already down the learning curve, so you don't get charged, and that's what happened to us. We were very early in the process, so people wanted to charge us double just for their own learning curve. And some questions that you should ask them are down at the bottom. Check real references, what went well, what didn't go well. Workers' compensation and liability insurance is really important. Have an umbrella policy for yourself if you're hiring contractors, to make sure if somebody gets hurt in the process, you won't have the liability. Detailed estimates, exact schedules. Make sure the permit is not in your name. The permit is specific to the person responsible for the work. Sometimes the contractor will say, why don't you go down to the city and give, why don't you get the permit? Because you're not responsible for getting the work done. Okay. And be leery of low bids. We've, been through the bidding process, and oftentimes you'll get one that's really low. And guess what? Contractors make 75% of their profitability based on change orders. And that's what's going to happen to you, guaranteed. So be careful of those. So here's a list of resources and others. And somebody asked about bidirectional charging, which is coming on fast. We recommend, if you're going to buy an EV, ask if it has the capability, because we want to set forth the intention that every single vehicle should have bidirectional charging, because batteries are the most expensive element of this thing. And again, if we could get your EV to take up the 4 to 9 period and make sure that you're not getting charged utility rates from 4 to 9. If you have solar in your house, you could charge that battery. That battery could charge your, power your house from the 4 to 9 period and save you a ton of money over the lifespan of the car and other things. But currently, there's only a few vehicles that can actually do that. And we want to make sure that all EVs have that capability going forward. But Brian asked a very astute question. And if you want to reach out to me personally, if you have a specific question about that, I'm happy to address it with you. Nick, other questions?
Let's
let Danica do her sum up and then get to those questions,
Yes,
I think.
We can do that. Danica, take it over.
Yes. So as always, if you have any energy code or CalGreen questions that come up, we have a code coach programs to help answer those questions for you. Next slide. And yeah, that's Nick and Robert right there, blessing us with their 80s rock star aura on the right. But so if you have any questions in receiving your AIA or ICC units, please reach out to my email listed on the slide. And in the next couple of days, you will get an email with this slide deck. So if you're interested in any of those resources, as well as the recordings, it will be in that email. And I'd like to, go back to the yeah, and I'd like to invite everyone to our upcoming in-person regional forum on November 4th, focusing on wildfire resiliency, and it's going to be in Santa Barbara. And after the forum, there's also going to be a tour of a local emergency operations center and regional fire communication center. And we have a couple of upcoming courses from December 9 to 11. If you want to see Nick Brown in person, we have a heat pump water heater installation training in person, and a couple of energy code course classes. And I'm also going to be launching a quick poll right now. Feel free to fill that out for us. It helps us think about what improvements and courses you guys are interested in for the future. And our team is starting to think about a 2026 course lineup. So if you have any feedback on how these courses should go, or if you have any topics you're interested in, feel free to do so. So I've launched that right now. And while you guys are doing that, I will pass it back to Nick and Robert for any last minute questions.
Thank you, Danica. You're amazing. You're amazing.
Great job.
That's so good. And thank you for posting our rockstar pictures from the Cape conference. And Nick will be sporting that mullet at the next training. We just want to let everybody know that. And I will be drumming in the background. Fantastic. So Nick, do we have questions, specific questions?
If you're backfeeding your master service panel with your EV, does that power go through the surge protect device?
If you
Bidirectional charging?
Yeah, good question.
I don't know the answer to
that. So when we installed the whole house surge protector, the instructions were to install it in the next slot down from the main panel, so that when the surge comes in from the street, it goes right to that thing. It doesn't go through all the rest of the circuits until it finds the surge protector. Because so you might have to install another one next to the the breaker that comes in from the car charger, if in fact you wanted to do that, because that power would be coming in that direction, and it would have to make its way all the way through the other breakers to that circuit breaker next to the main that you installed previously for that to work. So if you're really interested in doing that, but I think the failure, I don't want to speculate on that, but in comparison to the transformer blowing on the main line, I don't think you have the same liability with a surge coming from your car. Your car is not going to have some giant surge, magically coming through it. It's, the battery flow is pretty consistent. So I just don't think you have the same risk of a that's the risk. If a transformer blows or there's a lightning strike, that would come through the main line and then hit that surge protector and burn the surge protector instead of burning the rest of your house. So that's how that works. So hopefully that's helpful.
Did you have any idea of the cost of the Span and Schneider smart panels?
Yes. 5K
installed.
I believe so. I believe so.
Because I think I've heard more like 2,000, 2,500 for the unit itself.
Correct.
Okay.
Yeah.
And then Yen asked you to go back to your single trench slide.
Yes. Happy to.
Main electrical service in lieu of temp power. And I think that's right, isn't it?
Yes. There we go. Yes. That saved us a ton of money. I can't remember. I think The temp power, I can't remember the number, but it was expensive. It was really expensive. Because we would need it for a year and a month. The construction was a year and a month. So not to pay the rental fee for that thing. And again, the commercial rates for that thing is a big saver for people. So, highly recommend doing that work as the first step of the project. If you know where the panel's going, you should know where the panel's going to go, and it won't interfere with the existing stuff.
And that was SCE. Yeah.
That's correct. That's SE. The other advantage is they knew people were living there, so they really couldn't, sometimes there's a delay in the process that is inexplicable. And people have said, well, I've been waiting for SCE to turn on my, blah, blah, blah for, weeks now, and I can't get them out there, blah, blah, blah. But they had to turn it back on because we were living there, right? So there's an occupancy, that's immediate because you're still living there. That gives you, I think, some leverage in the process from our experience.
Yeah, we lived in a trailer in the backyard, so we had occupancy pressure on all our subs.
Yeah, that's good. Yeah, it's helpful. It's helpful to be close for sure.
All right, well, we're over on time. Sorry, Danica.
No worries. And I do not see any more questions. So I think we're good to go, and have a nice afternoon, everyone.
Yeah, thanks everybody.
You too.
Great. Thanks for all the great questions. And let us know if you have anything else we can do.
And thanks to you too, Danica. See you,
Yeah,
Robert.
thanks, Danica.
Bye.
Great job, Nick.
Enjoyed
Great job,
it.
Danica. See you guys again soon.